All right, so we're in section 2.4, congruent figures. We just talked about the fact that congruent means what? Congruent means what? Same, equal, okay? You do not have to write these terms down, okay? It's in your book, okay? But I want to talk for a minute about rigid motion, okay? What do you think of when you think of the word rigid? What does that mean? What? Tough? Tough, okay? I think of not flexible. So if something is rigid, it means that it's not like easily moved, okay? It's not necessarily flexible. So what we call rigid motion means that figures are only moving on the graph within certain rules, okay? So rigid motion, the opposite of rigid would be flexible. It's like, oh, okay, whatever I want to do, wherever I want to move it, that's where I'm going to move it, okay? Well, with these figures, they're going to follow a certain pattern, and I need to be able to identify the pattern. You know what the pattern is? Transformations, okay? So we learned 3 types of transformations so far. Say with me. Translations, reflections, and rotations, okay? So now I'm going to say, yes, they're congruent, but then I'm going to say why. Why are they congruent? And I have to identify the type of transformation that's happening between the 2 figures. That's today's lesson in a nutshell. Okay, so what the second 2 terms are basically saying is congruent means the same size. Okay, and that congruent figures are obtained by one of the rigid motion transformations. That's basically what I just said, is that one of those transformations will be your explanation as to why the figures are congruent. All right, so turn in your books to page 64. If you don't have your books, shame on you. Okay, I'm just kidding. But you need to bring them every day to class, okay? So that's in your class instructions. Very, very important. You need to be bringing your books to class. All right, I will have the graph up on the screen, though, too. Page 64. Okay, so here's some advice or some helpful tips that could help you identify congruent figures. Count the length and width in units to determine which figures are congruent. And then whenever you're listing the figures, we're going to use symbols, okay, to list figures. You need to make sure you list them in what? Alphabetical order. Okay, list them in alphabetical order. All right, so here's the graph. All right, congruent figures. Took me a while to to put all those shapes on the graph. All right, but it's really important that we had a visual, okay, on the screen, not just in your book. So basically, I copied what's out of your book underneath example 1, and I put it here onto the slide. Okay, I need to get my point labels on here. Remember, we said whenever we're listing figures, we need to make sure that we list them in alphabetical order. That's really important. Okay, so let's start with triangle MNP. Everybody see triangle MNP in green? Okay, all right, so I'm looking for a triangle that's congruent to MNP, and I do that by figuring out what the length, how many units are in the length, and how many units are in the height. Okay, so would I say that ABC is congruent? No. Okay, ABC is not congruent because it's 3 units high, not 2. All right, so what triangle is congruent to MNP? Jakari? DEF, good. Okay, and remember, listing them in alphabetical order is very important. Also, please note, okay, actually, hold on. I messed up here. A triangle needs to go in front of DEF. That I wrote the triangle symbol in front of, so basically if you're only reading the listing of the angles, you could tell that it's a triangle by the symbols, okay? So this is what you should have written on your notes, okay, is the sequence. You don't have to draw this graph. The graph is in your book, okay? So our notes today are not going to be as detailed on paper, because it would take us just an extreme amount of time to get these graphs written down. And what's more important is that we learn how to read the graphs, not necessarily draw them, okay? So we're doing a lot of watching and listening today, and we're doing some writing when we're writing the sequences. So the squiggly line with the equal sign means congruent. This is my congruency symbol. So you need to know and understand that that's how I'm showing that the two triangles are congruent. That is my congruent symbol, and you need to make sure you use that. Anytime it says identify the congruent figures, the symbols are very important. So you would lose points on a quiz or a test if you did not write your symbols. Okay, if all you said was MNP and DEF and you didn't have your symbols, that's not showing fully that it's congruent. The symbols show that. Okay, so that's a really good question. All right, everybody have that written down. Okay, let's try to identify if I have any other congruent triangles in the graph. Okay, so let's look for a minute at PQR. Do you see any other triangles on the graph that would be congruent with PQR? You see any? Has to be exact. Sam? Tati?
No.
No, there are not. Because PQR is 4 units tall, okay, height, length, however you want to say it, and there are no other triangles that are like that. Okay, so now let's look at ABC. Triangle ABC. Okay, is there a congruent triangle to ABC? Chloe? JKL, very good. And we're just going to try to get in the habit of calling them out in alphabetical order. So we're all on the same page, okay? So if one person's writing LKJ and the other one's doing KJL, and we're all writing in different orders, it becomes very difficult to grade, okay? And then there's a reason we write them alphabetically, okay? And we'll talk more about that in just a second. All right, so we're saying that JKL and triangle, sorry, my DEF just got messed up. ABC are congruent, okay? So that's the first step. Okay, I figured out that they're congruent, but now why? What is my explanation? All right, so let's go back to MNP and DEF. Okay, I need to figure out what type of transformation, because remember, these are rigid motion. What type of transformation has now moved the MNP down to DEF? Is it a rotation, is it a reflection, or is it a translation? Okay, what rules? Okay, so I know I have rules for translations. I know I have rules for reflections and rotations. Okay, does anybody have an idea of what's happening between the two figures to move it? Robbie? Translation. It is a translation, and here's why. Okay, do you see the figure turning at all? No. Do you see it flipping? No. Okay, so a translation is, yes. Now here's how you identify what the translation is. You have to compare what we call corresponding angles. This is like number 14, where you're identifying corresponding angles. Corresponding angles are in the same location on both figures. So what angle would be corresponding to P? What angle? F, because it's in the same spot on the other figure. So you have to compare corresponding angles to figure out the translation. You can't say, oh, from P to D and count. That's not the same angle. All right? So we can just pick whichever one. From P to F, how many do I move to the left? I move one to the left. So I say translation. You need to write this part down. Translation, one left. Okay? Now, again, from the corresponding angles, P to F, how many down? 1, 2, 3, 4, 5. 5 down. Okay? So that's my translation. That's how I moved the figures. Again, to prove congruency, I have to have an explanation. On my explanation is that it followed one of my rigid motion transformations. Rotations, reflections, or translation. All right, let's look at the second pair. Think to yourself for a minute. What rules is it following? Okay, a lot of times there's not just one answer. Okay, a lot of times there's not just one answer. What do you guys think? Anybody want to volunteer the answer? Anybody new? Anybody different who hasn't volunteered? Okay, what's happening between ABC and JKL? Kendall? It is a reflection where? What is my line of reflection? This was on your test. The x-axis. It's reflecting across the x-axis. Okay, so I say a reflection across the x-axis. Tati? Okay. All right, moving on to example 2. And between examples 1 and 2, this is really what you need to know. So there's not, I guess I would say there's not a ton of material in the lesson. It's just important that we understand what's happening in each one of these graphs and that we can read the graphs. Okay, so in example 2, something is happening between the red figure to the blue figure. Now, my instructions say that they're congruent. My instructions say that they're congruent. Okay, it says the red figure is congruent to the blue figure. Describe a sequence. So if it's a sequence, a lot of times more than one transformation is happening of rigid motions between the figures. That's what the instructions are going to say. Okay, so I need to figure out what's happening here. Can I just translate it from the red to the blue? Can they translate? No, because translations don't turn. Are you paying attention? You paying attention? Look up here, because there's nothing to write on your notes. So everybody should be looking up here on the screen. All right, so, okay, so it's not a translation because the red figure is turning to form the blue figure. Everybody with me? Is it a reflection? Is it just a straight flip in the other direction? No, it's not a reflection either. So the only one that leaves is a rotation. So now I have to figure out from the red figure to the blue figure, am I rotating counterclockwise or clockwise? Now, don't be fooled by the fact that the blue figure is on the right side of it, because I could also shift it once I turn it. But how am I going to turn it so it's facing the same direction as the blue figure? All right, what do you think, Sam?
You can do it clockwise or counterclockwise.
How many would you go if you went clockwise? No. No. You would go 270, but I would just say 90 degrees counterclockwise. Guys, if you turn, and you've got to kind of visualize this, but if you turn the red figure 90 degrees counterclockwise, now it's facing the same direction. All right, and I'll show you on the graph. Okay, if you turn it 90 degrees counterclockwise, now it's facing, all right, and you know that's CCW, okay? Now it's facing the same direction as the blue figure, but is it in the same location? Is it in the same location yet?
No.
No, so I need to choose any point on the figures to figure out how it's shifting, okay? It doesn't matter as long as they are corresponding points. So from the top right point, I go 1, 2, 3, 4 units up. So I would say that it rotated 90 degrees counterclockwise, and it translated 4 units up to get from the red to the blue. It turned counterclockwise, and it shifted 4 units up. All right? Now, that in a nutshell, that's everything. That's like your whole lesson. But we're going to see figures turning all different directions, flipping, reflecting, translating. So I want to show you a couple more, okay? Just a couple more that would help us maybe understand this a little bit better. All right, so we have these two figures. There is not only one correct answer, okay? There are multiple answers that would be acceptable here. All right, so as long as you can give a justification of where it's moving and how, then that's really all we're looking for, okay? So your answers might be different. I want you to tell me from the red figure to the blue figure, they are congruent. Now you are going to describe the sequence of rigid motions that get me from the red figure location to the blue figure location. Go ahead and do that. Okay, from the red figure to the blue figure, you must choose corresponding angles. Okay, well, they're both in the same direction. Do you agree? So you can choose any of them, top right, top left, bottom right, bottom left. Okay, but you're figuring out now how many units am I going up and left to figure out the translation. Okay, so I'm translating. Okay, someone different. Someone different tell me what's my translation. Ashlyn, what did you write for translation?
5 units up, 3 units left.
Okay, do you agree with her?
Yes.
Okay, very good. Awesome. Okay, and guys, if you had picked any other point on the figure, it would have been the same thing. Okay, 5 units up, 3 units left. All right, not too bad. Okay, now I'll tell you, the rotations are the hardest ones. Okay, the rotations are definitely the most difficult because you have to figure out, okay, once you figure out the direction, you have to figure out where the new figure is going. All right, in order to, this isn't just a straight translation. I wish it was. Translations are pretty simple. Even reflections are pretty simple because you just say which axis. All right, rotation is definitely the most difficult. All right, so let's figure out how it's being rotated. But once it's rotated, it also has to be translated. Has anybody figured out how the figure is going to rotate? How's the figure going to rotate? Get the same volunteers. I got a bunch of shy people in this class. How is the figure rotating? Is it turning clockwise or is it turning counterclockwise? Remember that long side has to be on top now. Okay? And the short side needs to be slanted like diagonally to the right. Milani?
I said it rotated 270 degrees clockwise.
You could say 270 clockwise. Actually, not 270 clockwise. It would be 90 clockwise. Or 270 counterclockwise. Okay? Because you are turning it in the clockwise direction, but you only need to make one turn, all right, to get there. All right, so it's 90 degrees clockwise. All right, now, here's the challenge, all right, and here's the direct tie into what we just tested over. If I'm turning 90 degrees clockwise, that would be 270 counterclockwise. Doesn't matter which way you look at it. What am I doing to my XY value to rotate the figure? I flip them, and then I do the opposite of what? I flip them and I do the opposite of, not the Y. If I'm going counterclockwise 270 or clockwise 90, I flip them and do the opposite of X. So I need, for the top point, I'm going to flip them and do the opposite of X. I flip them again and do the opposite of X. And I flip them again and do the opposite of X. And now this tells me where my new points go. Okay, so 1, 4 goes here. 0, 2, 0 up 2 goes here. And left 3, wait, hold on. Did I do something wrong? Yeah, I plotted the over 1 up 4 goes here. Oh my goodness. Sorry guys. All right. I don't know what I was thinking. And then 0, 2, and then negative 3 up 4. Okay, so now I've rotated it, and now my figure is in the same direction. Okay. But now it's still not in the same location. How is it being translated? How is it being translated? Just make sure that you're comparing the same points. Okay, now that it's in the same direction, you can choose any of the points. How many units am I translating to the left? All right, just tell me.
Right 3 down 1.
Translate right 3, down 1. All right, and that's how it moved. Okay, so the rotations are the hardest because you have to figure out where the new figure is going. So you have to do a little bit of legwork from what we just tested over. All right, definitely the most difficult, but if you understand that, that's everything you need to know for section 2.4.